Hello and welcome back to this session about user-defined functions. So whenever we want to reuse or repeat the same or very similar code more than once, it may be worth writing a reusable function. And by doing so, this can help us to make our code more readable. Functions are nothing new, and we used a lot of built-in functions so far. But first of all, let's create a list L containing of 4 integers 3, 2, 5, 6, and we already know the function, the built-in function print, so we can print our list. And for example, there's also the function sorted, where we can sort our list in an ascending manner. So here we have 2, 3, 5, 6. And sorted actually creates a sorted copy of L. So if we want to really sort our list L, we have to reassign L. So now let's print again L. And here we have the sorted list L. And we already know methods, which are functions that are attached to specific objects. For instance, we know that the list object has the method append, where we can append another element to the end of the list. So for example, we can here append the element 7 to the end of the list. And let's print out our list again. And there we have 7 at the end of the list. And as a general rule, functions work for different objects. So you can print out a list or an integer on float with the function print. And in contrast to that, methods are functions specifically designed for particular objects. So for example, here the append method is a particular function for the list object. Alright, and we already know more functions. So we know the length function, which calculates the amount of elements in our list. So we have 5 elements. And we already know the min function, which calculates the minimum element of our list. So it's 2, and we also know the max function. And we have already seen also the sum function, which takes the sum over all elements in our list. Yeah, we have seen that there are built-in functions like minimum, maximum, sum, and one could think that there should be also a mean function which calculates the mean of our list. And if we try to apply the mean function to our list L, and then Python says that the name mean is not defined, so there is no mean function. And now we can create our own user-defined mean function that calculates the mean of a list. And before we start creating the function mean, we should first of all think about how to calculate the mean of a sequence of numbers. And actually we just have to take the sum of all elements divided by the amount of elements itself. So let's check what we get here. So we have here the sum is 23 and the length is 5, so 23 divided by 5 gives us 4.6. And now what we can do, we can define our new function mean, and we have to start with the keyword def. Here you see it in green, it's a keyword, and then we say mean, so our function should have the name mean. And then within the brackets we define a parameter x. So x could stand for a list or another type of sequence like a tuple or so on. And then we have to make a colon, and then if we press enter, we see that Python automatically creates here an indent. So this is called the function header, where we define the function. And now here is the function body, where we define what the function should actually calculate. And here we have to make an indent. So the function should calculate the sum over our parameter x divided by the length of our parameter x. Then we can delete here the empty line. And then we have to define what our function should actually return. So here in the function body we define what the function should calculate, and then in the end we should define what our function should return. So we use then the keyword return, And the function should return us the mean. So now we can run the cell. And here once again, so this is the same code here if you compare it. And then what we can do, we can call the function by passing the argument L to the function. So L is our list, and the function expects an argument for the parameter x. So our argument is the list L. And let's see what we get here. So here we get 4.6. And we can also do this more explicitly. So we can call the function by saying, okay, our parameter x should be our list L. So this is actually the same as above. Yeah, and our function should not only work for lists, but also for other sequences like tuples. So we can define a tuple T with the elements 4, 5, 6, 7. And then we should also be able to calculate the mean of our tuple, because if you look at the function body here, so we calculate the sum of a sequence divided by the length of a sequence, and the sum and length functions should also work for tuples. So our function, our user-defined function mean should also work for tuples. Let's see if it works. And here we are. And what I also want to show you, so there's no need to define here a variable mean. We can directly say, okay, please return me the sum of our sequence x divided by the length of our sequence x. So this should also work. And let's run it again. And there you can see, so it also works. Alright, so let's move to another example, and we assign the integer 7 to our variable a. And then we can calculate a squared. So it's 49. Yeah, and then if we want to change a, so let's say we want to change a to 8, then we can rerun here the cells and get 64. And whenever we want to reuse a code, we can also define a function. So we can define the function square with the parameter x, and the function should return us the square of our parameter x. So let's try 4 and call the function by passing the argument 4. And the function gives us 16. And the same as above, we can also make it more explicitly by calling the function saying that the parameter x should be 4. So this is the same. But actually what we have to do, we have to pass an argument to our function. So if we just call our function with no argument, we get an error message. So here you can see our function square is missing one required positional argument x. However, what we can do, we can set a default value to our parameter x. So we can define our function square 2 by saying that the default value of our parameter x should be 2. And the function should return x squared. So now if we call the function without any argument, the function automatically applies our default value too. So now we would expect here 4 as a return of the function. And correct. And of course, the function can also be called with a new argument. So for example, 4 gives us 16. And same as above, we can make this more explicitly by saying our parameter x is 4. And this also works. Alright, these were the basics of user-defined functions. In the next two sessions, we are going a bit more into detail. So hope to see you there. Bye.